So now I will start. As you have gone into the, you have seen the basic phacoemulsification by the stalwarts, Ruchi, KPS and Mohan. Now we will go to the basics of the phaco-dynamics, and in that I will not cover the total phaco-dynamics but few tips. As you know, the Kelman who introduced the phaco, and here the study of the fundamental principles are very, very important, that inflow rate, outflow rates, vacuum, phacomodulation along with the microsurgical maneuvers with the different types of grades of cataract. And the true understanding will only help to in logical setting of the machine parameters and adaptation of different surgical techniques. Even the most modern machines, we always feel that machine is costly. Machines will not give good and adequate result as compared to an older machine if the principles of phaco-dynamics are not well understood. So, know the phaco-dynamics and let become the independent of the machine. Whatever the machine is there, that can be applicable for the phacoemulsification. Now this, I think everybody knows, the position 1, 2 and 3. These are independent positions, but 3 position is always the position with all 3, 1, 2 and 3. See, to provide the source of fluid infusion into the eye during the surgery, there is no linear control of the infusion, except, now till now, it was a gravity fed reflex. It means it was fluid comes in the eye with the gravity. Now there is no any financial interest but in the centurion, where this infusion depends on the intraocular pressure. So whatever the intraocular pressure you want to maintain, that pressure can be maintained by the infusion in the centurion machine, and height of the bottle in normal case determines the relative infusion pressure and the flow rate during the surgery. The fluid inflow rate should be greater than the flow outside, so that the anterior chamber will remain filled. Now here there is a linear control of the vacuum, and a flow top of the position 2 provides less vacuum at the flow than the middle or the bottom ray. It means if there is a vacuum, at beginning it is low, but at the end it is high in the same step. It means in the step 2. So this step is gradually going to step 3, and because of that there is a linear control of the vacuum. To create the vacuum and the aspiration flow of the fluid, the phaco machine must have a fluid pump. It is very, very important, and the most common types of fluid pumps are peristaltic and venturi. Other pumps are not useful for the phacoemulsification. Now there are 2 primary sources of fluid outflow during the phacoemulsification: the outflow from the phaco probe created by the fluid pump, that is aspiration tubing, and secondly leakage of the fluid from the incision. Because of these 2, you get the fluid goes outside. Now there is a linear control of the ultrasound energy also. And note that the position 3, we are already engaging the full function of both positions, that is position 1 and position 2. And the irrigation is on, and on the vacuum and the aspiration level is at the highest preset level. Ultrasound energy should only be applied once the tip of the phaco probe is in contact with the part of the cataract. While this amount of the ultrasound energy, we are keeping the frequency constant, but we are increasing the stroke length and therefore the total amount of the energy. So I am going to tell you how much is the stroke length and this. Now this is the phaco machines made up of console, handpiece and foot pedal. So basically the hands, 2 legs and 2 eyes and also 2 ears are required for the phacoemulsification. And now you can see the phaco probe. So this you know so that the different tips and aspiration port, the stroke length, irrigation port, the silicon irrigation sleeve, and the handpiece. So this is what is there in the handpiece of the FECO. Foot pedal, it is a 3 positions of the foot pedal. The FECO dynamics consists of 3 basic steps: irrigation, aspiration, and FECO emulsification. Now this is you can see the irrigation bottle, and then you will see how it works, the pump, and according to the whatever fluid goes out, the gravitally it comes down. Now the most FECO machines irrigation provided by the gravity fed through the space between the titanium FECO tip and the sleeve. The amount of the irrigation is determined by the bottle height relative to the patient's eye, and by the sleeve diameter, and most importantly by the loss of the fluid from the eye. So whenever the incision is larger, the fluid goes out and we feel the surge is happening. But that surge is because the incision is large, FECO probe tip is small, and that is leaking out. That causes the surge, and that surge causes the posterior capsular rupture. Stable anterior chamber is very, very important whenever you are going for the FECO emulsification. And this dynamics irrigation, aspiration, leakage from the wound. It means you will have to see irrigation, aspiration, and leakage combined. And when you see this combined, flowability attract and hold nuclear material or a ultrasonic probe. So that is very, very important whenever we think that machine is working. Now here how this works. It is a jackhammer effect. Is the physical striking of the needle against the nucleus. It is a physical phenomenon. It happens. And the cavitation effect is created energy that is released when the micro bubbles implode. The acoustic wave transmitted through the fluid in front of the tip. There is an impact of fluid and lens particles being pushed forward in front of the tip. Now here, when the FECO needle moving ultrasound speed cutting intense zone of the high and low pressure. Now here you can see low pressure created with the blockade movement of the tip literally pulls the dissolved gases of the solutions. It means the solutions creating micro bubbles. And forward tip movement then creates a equally intense this zone of the high pressure. And this produces compression of the micro bubbles until they implode. 75% of the micro bubbles implode to create a powerful shock wave, and that radiating from the FECO tip in the direction of the bevel with the annular spread. And 25% bubbles are too large. The too large bubbles are too large to implode, and these micro bubbles are swept up in the shock wave and alternate with it. So radiate with it, it removes. Now as the moment of the implosion, the bubbles create a temperature. You just remember, temperature of 13,000 degree Fahrenheit. And because of that, though we operate a case, we see cornea is not damaged. And secondly, we see the escape. The cause is because of the temperature which was required to create a bubble. And also the shock wave. Now this shock wave, if you are counting, that is 75,000 pounds per square inch, PSI. So that shock wave is created. And because of both pressure, though it is not directly affecting the cornea, directly not affecting the posterior capsule, this may cause the tears in posterior capsule. And secondly, because of the high pressure and because of high temperature, the endothelium is damaged, and because of that, secondary straight keratitis is seen. Straight keratitis is seen in cases of the matured cataract or in cases of the nuclear cataract. Now the FECO power depends on. Now here the amplitude is equal to stroke length, the length of the needle movement. This length is generally 2 mils. Now, what is 2 mil? It is a thousandth of an inch. The 1,000th of an inch is called as mil. So that is the length of generally length. It should be up to 6 mils. Most machines operate from 2 to 4 mil range. So whenever you are purchasing the machine, this is very important that you will have to ask how much mil is the length. The frequency, the speed of the needle movement, it is determined by the manufacturer of the machine. The phacoemulsification needle moves at a frequency between 35,000 to 45,000 cycles per second, that is hertz. So this is the movement of the needle. Now few concepts, the maximum phaco power. The maximum phaco power is preset by a surgeon. So whatever we want, we preset it, that is maximum phaco power. It determines the maximum obtainable ultrasonic energy when the foot pedal is fully depressed. So it means you must know when fully depressed, it is going to happen. The actual phaco power. The actual phaco power in a machine with a linear foot pedal control is proportional to the foot pedal position and denotes the power actually being delivered at the given time. The effective phaco time, EPT. Effective phaco time is the total phaco time at 100% phaco power. If your phaco power is 50%. So there that is measured as 100% and then it is calculated, and it can be less than the total pedal time. So EPT, which is an much accurate index when you are thinking of the use of the phaco energy. Now rise time. The rise time is a measure of how rapidly the vacuum builds up once the aspiration port is occluded. The pump flow. The pump flow is a measure of the radiational speed of the peristaltic pump head, which is in turn determines the flow rate and aspiration, and these changes from machines to machine. So changes are from machine to machine. Now here I want to just look at that OD and ID. OD is outer diameter, ID is inner diameter. Whenever you see the tip, you can see 1.1 millimeter OD and you can see 0.9 millimeter ID. Then 0.8 millimeter, 0.6 millimeter. Then you can see 1.1 and here 0.9. And 1.1 and 0.9, that is Alcon sphere tip. So these are the tips where, though we are thinking it is a 1.1 like that, but internal diameter varies from 0.9, 0.6, 0.8, it is like that. So that matters, because from here all the material is going to be absorbed. Now this handpiece, it is a magnetostrictive handpiece was used before. Now this piece, the first was used and has now been phased out. It uses an electric current to induce a magnetic field which results in the linear movements of the ultrasonic tip. The electromagnetic field is generated by a coil of the wires wrapped around the handpiece. But now it is no more used. Now what is used today is a piezoelectric handpiece. Now piezoelectric handpiece uses electric energy to reorient the piezoelectric crystal, which is in turn translated into the linear movement. So the piezoelectric transducer requires a direct electrical contact to be made with the crystal. So whatever the crystal they say, so according to the 2 crystals, 4 crystals, so the phaco works better or best. Now these are the pumps. You know the peristaltic, scroll, venturi, diaphragmatic and rotatory, but normally we use only 2 pumps, and that is a venturi and peristaltic pumps. So other pumps we are not using, but this is the venturi and peristaltic pump we use. So here so this is the peristaltic pump, and then the scroll pump we are not using. Then the venturi pump, here you can see the compressed gas which goes in the opening A, and then it happens in the aspiration. Now it is indirect, it is not connected with the B, chamber B. And this diaphragmatic is a difficult pump. We are not using that. Advantages, I don't want to go into detail. Now the linear control. The linear control, pressing the foot pedal leads to gradual rise of the parameters from 0 to preset with a linear relation to the foot pedal control. More surgeon control. The panel control, the parameters reaches the preset panel maximum. It means if it is linear, whatever you want, it goes in the last. If it is preset pedal, whenever you put your foot on this, whatever you want that there should be 250 vacuum, there will be 250 vacuum. Chashma is with me. So, this is what, and now you know that there are also this is the range of this one, the FECO modes, you know the continuous mode, pulse mode and burst mode. Now in the burst mode, maximum power is delivered at the interval which depends upon the amount of depression on the foot pedal. So that is a burst mode. So this is you can see the pulse mode, and in between this is a pulse mode, this is a burst mode. So you can see the maximum energy is dependent on the foot pedal pressure, and then hyperpulse, and this is the hyperpulse and hyperburst mode. Pulse duration of the 120 per second and burst with is 4 millisecond in new machine causes less heat generation and smooth FECO power. Now this is what is the duty cycle. You can see the 50 or 80 and 20. So accordingly it increases the FECO power. Now the tips, you can see the 0 degree tip, 15 degree, 30 degree and 60 degree, and also the 45 degree. So these are the tips. Surge. When outflow of the fluid is increased, then inflow of the fluid from eye, especially after sudden disocclusion of the occluded FECO tip. How it happens, you can see FECO occluded by the nucleus tubing collapse, break up the occlusion with eating the nuclear piece, no negative pressure. Now fluid aspiration is more due to the sudden tubing expansion, AC shallow and unstable. So this is what is I was telling about. Now how to prevent low fluid and vacuum, compliant aspiration tubing, venting, increasing bottle height, reducing tip size, aspiration of bypass port and cruise control. So this can happen. Low aspiration flow rate and vacuum setting can make the procedure slow, increase the rise time but decrease the surge. Then the non-compliant tubing are less collapsible and causes less negative pressure, hence causes less surge. Then the machine has sensor which detect occlusion and release fluid. Here to re-expand tubing and preventing the excess of outflow, hence decreases the surge. Can see the increased bottle height causes more inflow to maintain the entire chamber. In the small FECO tip with the internal bore 0.6 mm restricts flow and decreases the surge. The ABS tip allows irrigation fluid to be sucked in this shaft and prevents the surge. Now, cruise control is a disposable flow restrictor attached between the FECO and aspiration tubing. So this is what that you can, newer technology are there, and I will just go through the one video. See now this, I am operating on the Centurion machine and I want to just show you, but the parameters are not seen here. So it is with the parameter, and that was important, but I think it has gone on the other side. This is the Rexis are doing, and you can see the cataract is slightly harder cataract. And I am operating on the Centurion machine. This is a Rexis I am doing. the hydro dissection, but this was to show now you can see the parameters on that side. See the vacuum, and you can see the intraocular pressure there. It is 70. Aspiration and vacuum you can see, and now you see I am going here and doing you can see in this nucleus, I am chopping. So you will have to enter in and then chop. Two tips should be slightly away from each other. Then you have seen the intraocular pressure is constant. That is 70. Now again you can see the vacuum. It is increasing constantly. I am going inside. And you see this. And again making the another piece. And that you will have to separate that piece till middle of the nucleus, center of the nucleus. And if it is not separated up to the center, now again you see, then the fibers which are there behind to the posterior portion of the nucleus. So these leathery fibers, they will not be separated and piece will not come to you. Again you see this, and you can see in the center the fibers were not separating. So I tried to separate those fibers. Again I am going in, and here see this, and then as everything is separated now I am lifting the piece. You can see the piece is lifted, and this is the fallibility. It means the piece is coming to the tip. Piece is coming to the tip, and you can see the vacuum there, and because it is going 490 you can see, and the aspiration, so that you can see how the vacuum helps you for this. Now once I am again rotating it, and see they were not separated. I separated it because of those leathery fibers. See the vacuum, though this is but on second day, in such cases you are going to get stride keratitis. You have seen the phaco was very good, but because of the high temperature and because of the high pressure used, so that is going to happen. So another thing I want to tell you is, now see this. So this is you can see now here, I am chopping. And you can see, though it is seen as a white cataract, it is not an white but very soft white cataract. And that may, because it appears like a white cataract, but it is very soft. So if you use more force here, so that can cause the posterior, this capsule damage. Now here you will see this now. It comes in the less time than the soft nucleus. See this, because this is the soft cataract, and you will have to see that. You will have to see before this in the slit lamp examination, and then you can go ahead. So this was about the phaco dynamics and how that is applied, and thank you very much.